Okay, everybody. Today's lesson, the law of sines. Now, what happens if you got a triangle and it's not a right triangle? I mean, there's no hypotenuse. It's not a right triangle. It's just a triangle. It's any old triangle, okay? If you have any old triangle and you know a pair of opposites, we use the law of sines. So the law of sines is set up like this. Here's my triangle. It's set up as two fractions. Opposite 1 over the sine of theta 1, so opposite, is equal to the opposite side over the sine of its opposite. Okay, so then I made up a problem. It's mostly solved, but we'll go through it as if I didn't solve it. But in this example, you don't know that or that, but let's just take this where it is, okay? So the first thing I said is you notice, do you have a pair of opposites? We said yes. We got the 12 as a side, and the 38 is the opposite angle. So we set it up, okay? So what we can do is, since we have the 72, I could find its opposite. So it's all about opposites. Side, opposite angle, find the side, opposite angle. So I set it up. I just put it in here. So I put opposite 1, which is x, over the sine of 32, sine of its angle, is equal to the 12 over the sine of 38, okay? So opposite side of the sine of its angle, opposite side of the sine of its angle. Then to solve it, I just multiplied by sine of 72 to get x by itself, and I just used my calculator. Now I have to be careful with my calculator with parentheses, but I just went just like this. I just went 12 sine of parentheses, I got parentheses 72, close your parentheses, divided by sine of 38, close your parentheses, and I get an answer of 18.54. Pretty easy. Okay, so then we said once we get this, if I want to find more of the triangle, I know in a triangle there are 180 degrees in three angles in a triangle. So to get this angle here, I add these two and I subtracted from 180, and I get this angle to be 70. Okay, if that's the case, then I could find another pair of opposites. It's all about the opposites. So I could find this side, we called it y, or opposite 3. So I go y over the sine of its angle, y over the sine of 70, and I use the 12 and the sine of 38, okay? So opposite sine of its angle, opposite sides of its angle. Then I multiply by sine of 70. I use my calculator, 12 sine of 70 divided by sine of 38, and I get an answer about 18.3, okay? That's it. Now on the back side, I rewrote the formula. I rewrote it just slightly. I just wrote it upside down, but the angle on top, okay? So if you want to find an angle, an unknown angle, we did know you're going to have to use the inverse button, but if you want to find the angle, I just like to write it slightly different. Same formula, it's just written upside down. So here's what we did. In this example, we knew one angle, and that's it. But we still had a pair of opposites, okay? We still had a pair of opposites. So if you have a pair of opposites, you can find an opposite, okay? So I've got 12, 64, and 10 and theta 1. So we set up into the law of sines. So we went sine of theta 1 over 10 will equal sine of 64 over 12. And that's what I wrote. Sine of theta 1 over 10 equals sine of 64 over 12. Then I multiply both sides by 10. I got the 10 sine of 64. I used my calculator, and I got a decimal. I'll show you what I did. I went 10 sine of 64, close the parentheses, divided by 12. And I got a decimal. Now that can't be the angle, but then remember, oh wait a minute, I'm looking for an angle. Always push the inverse button when you want to find an angle. So I just went sine inverse of that answer, and I got about a 48.5 degree angle. That's an angle, okay? Always when I find an angle, you push the inverse button. Okay, so then I went back to my triangle, and I knew I could find theta 3 because there's 180 degrees in a triangle. So I went 64 plus my 48.5, and I subtracted that from 180. I got 67.5. So I put that in there. So 180 degrees in a triangle. Then finally, if I want to find the last missing side, which should be theta 3, so I don't know this side, okay, I can again set up my opposites, but now it's the sides. I'm going to go 12 sine of 64, and I'll do the sine of 65 over this opposite side. So we called it opposite 3, okay? How's that? Op 3. Here, I'll put that in there. Opposite 3, or you can call it whatever you want. So we went opposite 3, the sine of its angle, 67.5, equals the 12 over the sine of 64. Multiplied up to get opposite 3 by itself. So in 12, sine of 67.5, close the parentheses, divided by sine, oops, not cosine, sine of 64, and I got an answer about 12.34. Okay, that's all I have. If you have any questions, come see me.